Hello everyone. Welcome back to the AWS Certified Solution Architect Associate Bootcamp. In this video, we'll cover a critical topic, federated identity in AWS. This module directly maps to the certification task of determining when to federate a directory service with IAM role and understanding how resource policies and identity policies are used to control access. By end of this video, you will have complete understanding on what is Identity Federation using SAML 2.0. We'll look at Zero Trust architecture in AWS. We'll compare identity versus resource policies. We'll also review inline versus managed policies. And at the end, we'll talk about least privileges, all of which are key in designing secure, scalable AWS environment. Let's get started. We'll start with the basic. I'll explain Identity Federation with a simple example. Assume we have an AWS account A, with resources like an S3 bucket and EC2 instance. Now who can access these resources? First of all, account A root users and IAM users, they can access. Then any organizational users from a different AWS account, maybe from account B, and root users and IAM users of account B can also access these resources. When you share access within your organizational AWS accounts, it's called delegation. You can also share access with external identities, like with your corporate users. If you have a corporate Active Directory or any SAML-based identity provider, you can extend the access to your corporate users. And the corporate users can access AWS resources using their corporate credentials. One more possibility, web or mobile application users can also access these resources via web or mobile application. And the application users can register via identity providers like Azure AD, Okta, Google, or any YDC compatible identity provider, or OAuth 2.0 compatible providers like Facebook, Amazon, and all. When AWS access is granted to external users via an external identity provider, it's called federation. Federation lets users from external identity providers access AWS without creating IAM users. You must be thinking, what are the use cases? One of the many use cases could be, your company uses Azure AD, but you want your users to access AWS console without separate AWS credentials. Or maybe you have your web or mobile applications and you want mobile or web application users to upload image or document to an S3 bucket. Creating individual IAM users for all web or mobile application users could be a nightmare. For that use case also, you can use Identity Federation. Now let's review what are the identity providers can be used for this Identity Federation. First, SAML 2.0, maybe your corporate Active Directory is the best example. Then YDC based or OpenID Connect based identity providers like Azure Entra ID, Okta, Google Workspace. You can also have a custom identity broker. You can also use Amazon Cognito. Amazon Cognito is AWS service for this web identity federation. You can also use IAM Identity Center and integrate all those external identity providers. Now let's review Identity Federation using SAML 2.0. SAML stands for Security Assertion Markup Language and 2.0 is the version. It's an open standard used by many identity providers like Microsoft Active Directory Federation Service or ADFS. Under the hood, SAML Federation uses Assume Role with SAML API. It's a STS API or Security Token Service API we have already discussed in the previous module. Now let's dive into SAML 2.0 based Identity Federation and understand how it works. Suppose you have an AWS account and want to share an S3 bucket with your corporate users through a web application. At your corporate data center, you might have a SAML 2.0 based identity provider such as Active Directory, And the user directory is maintained using a LDAP based identity source. As prerequisite, first you need to configure a two-way trust between your corporate identity provider and AWS. Next, you will create an IAM role with the necessary privileges to access the S3 bucket. In the process of identity federation, corporate users will send authentication request to the corporate IDP through the web application. The corporate IDP will authenticate this request using the identity source. And if the authentication is successful, the corporate IDP will send a SAML assertion token to the user. Using the SAML assertion token, the user will invoke assume role with SAML to obtain temporary credentials. Then STS will validate the trust policy and assume role permissions and generate temporary credentials for the user. Then the user will inherit the IAM role privileges and use the temporary credentials to access the AWS APIs, in our case, the S3 APIs. Since we have reviewed Identity Federation with SAML and we talk about IAM policies, let's dive deep into IAM policies. There are two broad types of IAM policies: inline policy and managed policy. Now let's review the inline policy first. You can create inline policy for a single IAM identity, maybe for a user or for a group or for a role, and that maintains a strict one-to-one relationship. This policy is not reusable and it requires considerable amount of manual work because you need to write inline policy for every identity separately. If you delete the resource, you will lose the inline policy. And in terms of who manages that policy, that would be you. Can you modify that policy? The answer is yes. And with how many principals you can attach that policy? That will be only one. Next, let's review the managed policies. Managed policies can be broadly categorized into AWS managed policies and customer managed policies. In terms of AWS managed policy, it's a standalone IAM policy created and managed by AWS. When new services are launched, AWS updates these policies. In terms of who manages the policy, it would be AWS. Can you modify? The answer is no. And with how many principals you can apply it would be many. The last is customer managed policy. Customer or you will create the policy for specific use cases where you will not see a standard AWS managed policy is available, or you might need granular access control. In that case, you can create a custom managed policy. You will have the option to change or update them as often as you like. When new services are launched, you need to update this type of policies. Since you are the sole owner of that policy, that is why you can modify this policy. In terms of how many principals you can apply to this policy, that would be as many as you want. This was the IAM policy details in terms of management. Now there is one more aspect of IAM policies in terms of where you can attach. An IAM policy can be attached with an IAM user, with an IAM role, with an IAM group, or maybe with a resource. If you attach an IAM policy with IAM user role or IAM group, it's called identity based policy. When you attached an IAM policy with any resource, it calls resource based policy. Now let's review one example of identity based policy and resource based policy, and here is a side by side comparison. The scope of this identity based policy is who can use a resource. That is why if you see, we have all the resource details. In sentence, you have allow for all S3 access to all S3 buckets. The second statement, it is saying allow all EC2 actions for all the EC2 instance available in that account. On the other hand, for the resource-based policy, you can attach a resource-based policy with Amazon S3, SQS queue, Lambda function, VPC endpoint, KMS, and Amazon DynamoDB. Every AWS services does not support resource-based policy. The easiest way to remember that scope is who can use a resource, or as an example, the user can read from an S3 bucket, whereas for a resource-based policy, that anyone from account B or specific user of account B can read from this S3 bucket. Resource-based policies are important in cross-account access-based scenarios. If you carefully observe the difference between the two, resource-based policy has principal component which is missing for any identity-based policy, because identity-based policy is attached to a user, role or a group. That is why we know who the principal is, and the principal is not required for any identity-based policies. However, resource-based policy identifies the principal explicitly. In terms of exam tips, please remember IAM groups are not supported as principal in any AWS policy because groups are not considered as identity. Group is an envelope where you can attach multiple IAM users. That is why you cannot assign any group to a resource-based policy. Now, if you pay attention to the principal components, you can see all the principals are listed with a specific format. Now, let's review what that format is. This format is called Amazon Resource Name or ARN. Amazon Resource Names uniquely identify AWS resources. We require ARN when you need to specify a resource unambiguously across all AWSs, such as an IAM policy, Amazon Relational Database Service or RDS, maybe tags or in any API calls. Now let's review the ARN naming convention or format. Here is an example of EC2 instance ARN. The first component ARN, this is just to signify this is an ARN. Then the next AWS, it defines the partition. The partition represents in which AWS cloud the resource is located. If you see only AWS, that means it is AWS private cloud. Apart from AWS, there could be two more options. For AWS China region, it can be AWS CN, and AWS Gov Cloud region, which is specifically for US government workloads or any high security workloads, you can see AWS US Gov. The next component is EC2, which signifies the service, and this service namespace identify which AWS product. If this ARN is for an S3 bucket, then instead of EC2, there you will see S3. The next component is AWS region. Currently we are using US East 1 or Northern Virginia. If you are using other region like US West 1, US East 2 or US West 2, you will see that region name. Then the next component is 12-digit AWS account ID, followed by the resource type. Since this is for EC2 instance, that is why we have instance. Instance is fixed for EC2 resource type, and the last part is unique ID to represent the resource, or this is the resource ID. The resource ID or the resource identifier, it could be name of the resources or the ID of the resources, or even it could be resource path. Now let's review some examples. If you have an IAM user, in that case you will see the ARN like this, and you can see the region is missing because IAM is a global service. EC2 was a regional service, that is why you have AWS region as US East 1. For any global service, you will see 2 colons consecutively. This is an example of Amazon S3 ARN. For S3, you can see the AWS region is missing, account ID is missing, and resource type is missing. Because Amazon S3 bucket should be globally unique, and with that bucket name, AWS can identify in which region it is, which account ID holds this S3 bucket, and obviously the resource type. That is why Amazon S3 ARN will not have any AWS region, account ID, and resource type tag. Now let's review zero trust. Zero trust means never trust, always verify. That is why when you will create new IAM user, the IAM user will not have any access, and it cannot access any AWS resource without any role or policy attached. In AWS, zero trust means no implicit trust. That means everything is auto deny. For every access, caller needs to validate its identity or the authentication, and also caller must have permission to access that service. That is why AWS recommends to validate every request using identity, context, tags, and IP address. And how to implement zero trust in AWS? You can use IAM role plus multi-factor authentication. You can use IAM policies with granular conditions like what is the source IP, what is the resource tag. You can also use STS for temporary credentials instead of distributing long-term credentials. And last but not least, you can use AWS IAM Identity Center. Now let's extend the zero trust concept a little further. We are going to discuss principle of least privileges. Let's understand using this scenario. Let's assume you have an AWS account, and in that AWS account you have one S3 bucket. Now who can access this bucket? In your organization, you may have one developer who needs to read or write documents or maybe create directory in that S3 bucket. You can also have one DevOps associate. The DevOps associate needs to access S3 bucket to store artifacts, or he needs to create new S3 bucket or delete existing S3 buckets. You can also have L2 support engineers who needs to access the S3 bucket to view application logs. You can also have security analyst who needs to review access logs, and you can also have external auditors who needs to access this S3 bucket for reviewing the audit trail. Now, how you are going to provide access to all these resources? Should you assign S3 full access to all? The answer is no. AWS gives you granular access control, and here you can see this screen is from S3 policy generator. You can see different S3 access levels. You have all the least access, then read access, write access, permission management, and tagging access, and the number is representing how many levels of access it has. Now when you are providing access, always give the permission what is absolutely required, nothing more. To start with, you can provide read-only access and then expand if needed. Please do not provide admin privilege at the beginning or by default to all the users. You can use action, resource, and condition field to scope the permission. If you want to provide read-only access, then instead of using S3 star, use S3 gate object and provide the specific bucket where you want to provide access. You can also use IAM Access Analyzer to review any unused permissions, and accordingly you can modify the access permissions. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at Cloud Expert Solutions. You are now one step closer to crushing your exam. See you in the next module.